Hi, welcome back to Unit 5, Day 10. This is Part 2, Intro to Net Ionic Equations. So before we go into what net ionic equations are, one of the things we learned in Part 1 is that in order for a precipitate reaction to occur, in order for there to be a precipitate reaction, there has to be a precipitate. So no precipitate, no reaction. And your question may be, well, why? Why does that need to be the case? If you're forming two new ionic compounds, why does one need to actually be a solid in order for it to be a reaction? So let's take a look again at what happens at a molecular level during a precipitate reaction. And we'll go back to the lead nitrate potassium iodide reaction. So remember the lead nitrate and potassium iodide, you start by dissolving them in water. And we dissolve an ionic compound that's soluble in water is going to break apart into its ions. And so that's what we're showing here, the ions. Now, when you mix all of those ions together, the lead ions and the iodide ions, when they interact, they sort of clump together because they're forming an insoluble solid. So they're not going to just remain floating around, they'll clump together. So if you look and compare the reactant and the product side, you see on the reactant side, everything's in an ion form. All you have are ions, but on the product side, you have a solid. So there's been a change there. And so the key thing is that in order for there to be a chemical reaction, there has to be a change. And when a precipitate forms, there's actually a change. You go from something that has all ions to ions and a solid. Now, to better see that, let's look at a case where no precipitate forms, so there's no change and thus no chemical reaction. If you take the reaction of barium nitrate with potassium iodide, so once again, they'll if you dissolve in water, they'll be floating around as ions, and you would think that, well, that they will switch partners and you can form barium iodide and potassium nitrate. So those are different, right? But if they're dissolved in water, they're still just ions floating around in water. So there's technically been there have been no changes happening here. You have ions on the left side, you have ions on the right, the same type of ions, right? Because no precipitate has formed in order to cause a change. So in the case where there's no precipitate that's formed, there's been no real change in the reaction. So what is an ionic equation? Well, it's really a simplified chemical equation that focuses on the things that change during a chemical reaction, right? And in a precipitate reaction, that would be the solid precipitate and the ions that form the precipitate. So to better see that, let's look at some examples. On the left side, you have the molecular equation, which is like the general equation. And these equations are balanced. And then on the right side, you have your net ionic equation. So if we take a look at the example here with lead nitrate and potassium iodide, going to form lead iodide and potassium nitrate, the net ionic equation for that will be lead 2 ion and iodide ion goes to form the lead iodide solid. So notice how in all of the net ionic equations we have our precipitate. I highlighted those in yellow just to so we can keep track. Precipitates are our solids. And then on the other thing we have in the net ionic equation are the ions that were used to make that precipitate. The same thing can be said for the second example. Our precipitate is magnesium sulfide, so the net ionic equation will contain magnesium ion and sulfide ion. For the last one, the precipitate is barium sulfate, so the net ionic equation will contain the barium ion and the sulfate ion, and of course the precipitate. So how do we get that? What are the steps for getting that? So first thing to do is to create what's called a complete ionic equation. So let me show you how you do that. Your reactants are aqueous. So remember, they're going to break apart into ions, and we can just write them out as ions. So instead of writing lead nitrate, I would write the lead ion, lead 2 ion, and then the nitrate ion. And I would also write the potassium and the iodine ion, because that's what I see here in this particle diagram, just all my ions, anything with a charge is an ion. Then on the product side, the potassium and the nitrate, the K and the NO3s, are still ions, so I will keep those as ions, but the lead iodide is a solid now, so I have to clump that together. So I have to write it and its chemical formulas. So that's my complete ionic equation. That's the first step. The next step is to get the net ionic equation by crossing out anything that's an ion on both sides. So anything that's the same exact thing on both sides, because that means it hasn't changed. So starting with nitrate, for example, the nitrate remains as an ion on both sides, so I'd cross that out. Then potassium, it's an ion on the reactant and on the product side, so I can cross it out. Now, can I cross out anything else? Well, no, because you have lead ion and iodide ion, so you can't cross those out because on the other side, it's a solid, it's not an ion. And then what's left will be my net ionic equation. So what I have left is my lead ion, my iodide ion, and then my lead iodide, which is my precipitate, my solid. All right. Let's see what happens when we do the same sort of steps for a case where there's no precipitate. So this is the barium nitrate potassium iodide reaction. So we do the same thing. Anything that's aqueous gets broken down into its ions. So I'm going to break down barium nitrate into its ions and potassium iodide into ions because they're aqueous. So they would be dissolved in water. On the product side, barium iodide and potassium nitrate are also aqueous. So again, I would still break those down into their ions. And this will be my complete ionic equation. Anything that's aqueous is broken down into ions. Now, the next step is to form the net ionic equation by crossing out anything that is an ion on both sides. So barium is an ion on both sides, nitrate's an ion on both sides, potassium is an ion on both sides, iodine is an ion on both sides. So wait a second, I've crossed out everything. And that speaks to the fact that I have no reaction. So I can't write a net ionic equation because there's really been no change. I have ions on the left side, I have ions on the right side. Really, there has been no change. So that's the steps for writing net ionic equations and sort of give you a sense of what they look like. The next thing that you'll see is a couple of practice videos for you to do if you're doing this as a play posit.